Hello everyone, good evening. So today I'm going to explain about register organization of 8086 microprocessor. Okay, generally this register organization in the sense because of 8086 microprocessor is a 16-bit microprocessor. That's why all the registers internally available in the 8086 microprocessor is size, its size is also 16-bit. That means all registers size is 16-bit registers. Okay. Now the category, the classification, or what are the various types of registers available in 8086. In that, the first one is general purpose data registers. General purpose data registers means these general purpose registers are used for to store the data temporarily. That means to store the data temporarily while during the program education the data can be stored in any one of the registers. Similarly, after execution of the instructions, sometimes the result is also available in these registers, that is for temporarily. Okay. So general purpose registers. So these general purpose registers are four in the 8086 microprocessor, that is AX, BX, CX, DX. These are the four general purpose registers. AX, BX, CX, DX. Here the X indicates the 16 bit. Okay, X indicates the 16 bit. X indicates the 16 bit size. Okay, and the 8086 can also use it, can also execute or can also store the 8-bit data also. So that's why each 16-bit general purpose register is divided into two parts. Okay, so now this is one 8-bit register, this is another 8-bit register. Okay, suppose when we want to operate the 8-bit operations with the 8086 microprocessor, then we can use these registers. Okay, here AL, AH. Similarly, BX is divided into two 8-bit registers, BH, BL. Similarly, CX, that is divided into two 8-bit registers, CH, CL, DH, DL. Okay, so L, here L means lower part and H means higher. So because the 16-bit is equal to 2 bytes. Okay, 16-bit is 2 bytes. So 2 bytes means one is lower byte, one is lower byte, one is this is lower byte, this is upper byte or higher byte. So this lower byte is the AL, can be stored in AL, and higher byte is stored in the AH. So that's why it is a AL and AH, BL, BH, CL, CH, DL, DH. Okay, so that is, this is the general purpose, and each general purpose register is also having one special purposes also. Okay, like what is the special purpose of AX register? AX register special purpose is it acts as an accumulator. Okay, it acts as an accumulator. It acts as an accumulator. Okay, it acts as an accumulator. Similarly, BX register. BX register is used for the memory location pointer. Okay, it can be used as, it can be used as memory location pointer. Memory location pointer per data segment. Okay, per data segment. Memory location pointer per data segment. Similarly, CX register. CX register purpose is it it can be used as a, it can be used as a counting purpose, counter for string operations. When we are using the string operations, so then we have to, then we have to count the number of bytes. Okay, so particularly for string operations or repeated operations, the counting purpose is required. Okay, so in that purpose, the CX register is acts as a default counter. Okay, similarly, similarly, DX register, DX register is it can be used as it can be used as IO memo input output ports. Okay, input output ports location pointer or simply input port addressing modes. Okay, in that addressing modes, IO ports addressing purpose, addressing purpose. Similarly, multiplication and division instructions also. Multiplication and division instructions also, the DX register can be used. Okay, so these are the each and every general purpose register is having one unique purposes. Okay, AX can be acts as a accumulator, BX register can be used as a memory location pointer for data segment, and the CX register can be used as a counter for string operations or repeated operations, and the DX register can be used as a IO ports addressing purpose and multiplication division instructions also. Okay, so this is the general purpose registers. This is the category of general purpose registers. This is the category of one category, that is general purpose registers. Okay, there are four general purpose registers. Next registers. Next registers are segment registers. Okay, segment registers. In the previous video, I already discussed about the segment registers. So there are four segment registers. There are four segment registers, that is core seg four segment registers, that is data segment register, code segment register, stack segment register, and extra segment register. Okay, extra segment register. What is the purpose of these segment registers? Segment registers can be used for store the segment base address, concerned segment base address. Okay, it can be used for to store the concerned segment base address. So this segment register's size is also 16-bit. This is a concerned segment register size is also 16-bit. Okay, next another register is a flag register. Okay, flag register, or it is also called as the PSW, that is program status word register. Okay, flag register, or it is also called as a program status word register. The flag register size is also 16-bit. The flag register size is also 16-bit. And in this 8086 microprocessor, there are totally 9 flags. There are totally 9 flags. And in the separate video, I will make it clear the flag register, what are the 9 flags, and what is the purpose of each and every flag. That I will discuss in the separate video. Okay. So first category is general purpose registers. Second one is the segment registers, and third one is the flag register, and next one is the index and pointer registers. Okay, index and pointer registers. Index and pointer registers. Index and pointer registers. Okay, so what are the index and pointer registers? That is, this is source index register, destination index register, base pointer. Source index register, destination index register, instruction pointer, base pointer, stack pointer. Okay, so these are the pointer registers. These are the pointer registers, and these two are the index registers. These two are the index registers. Okay, pointer registers and index registers. So what is the purpose of this? Index registers, source index and destination index register. Source index register is I'm drawing 4 segments. Okay, this is data segment, code segment, stack segment, extra segment. Okay, and these are the different memory locations. Each segment size is 64 kilobytes. These are the different memory locations. Each segment size is 64 kilobytes. Okay, each segment size is 64 kilobytes. This size is also 64 kilobytes. Okay, for this data segment, and this is the segment base address. This is the segment base address, and this segment base address is available, is stored in the data segment register. Similarly, code segment, code segment, code segment, this is the base address, and this base address is stored in the code segment register. Stack segment, stack segment, its size is 64 kilobytes, and this is starting memory location base address, and it is stored in the stack segment register. Similarly, this is the extra segment base, and extra segment base address is available in the extra segment register. Okay, so now what is the purpose of this index registers? These two are the index registers. These two are the index registers, and these three are the pointer registers. Okay, pointer registers. And now index registers. Index registers purpose is particularly these index registers are used for string operations, and when we are operating in the string operations, the source index is used to store the source index. It can be a 16-bit register, and similarly for particularly string operations, the source index registers is used for, it is used for to store the offset address. Okay, effective address or offset address. Already in the last video I told you what is effective address and offset address. Okay, in data segment, in data segment. Okay, similarly, destination index register. Destination index register is also used for string operations. It is used for, it is used for to store the, it is used for to store the effective address of, okay, effective address of extra segment register. Extra segment registers. sir, extra segment. Not to just extra segment. Okay. So that means suppose this is from here to here. Suppose if we want to transfer the data from data segment to extra segment, one segment to another segment, then in this data segment, this offset address is available in the source index, and this offset address is available in the destination index register. Okay. Now, what is the pointer registers? Base pointer, stack pointer, and instruction pointer. First, instruction pointer. Instruction pointer is instruction pointer is instruction pointer is to store the effective address for code segment. Okay. It is to store the effective address of code segment. Okay. Code segment. Code segment. That means suppose this is one particular memory location. This is one particular memory location. Okay. This is one particular memory location in the code segment. And in this code segment, this is the segment base available in code segment register. But the offset address is available in the instruction pointer. Okay. So then stack pointer. Stack pointer is, suppose this is the stack segment, and this is one particular memory location, one particular memory location. And in this segment, in this stack segment, this is the segment base, and segment base is available in stack segment register, and offset address is available in the stack pointer. Okay. Similarly, base pointer. For what I mentioned earlier is for string operations, the data segment and extra segment offset addresses are available in the source index and the destination index correspondingly, respectively. But normal operations for the data segment, the effective address is available in the base pointer. Okay. This is to store the this is to store the this is to store the effective address of data segment. Okay. So these are the different register organization. So totally, what are the register organizations? This is first general purpose registers, four general purpose registers, AX, BX, CX, DX, and each segment, each general purpose register is divided into two parts, two 8 bits. That is AL, AH, BL, BH, CL, CH, DL, DH. Okay. So that 8086 can operate 16-bit operations or 8-bit operations also. 8086 can perform 16-bit operations or 8-bit operations also. And each register is having one unique purpose. Okay. Similarly, next type of registers are segment registers. Each register size is 16-bit. There are four segment registers: data segment registers, code segment registers, stack segment register, and extra segment register. And these registers purpose is to store the these registers purpose is to store the like these registers purpose is to store the segment bases of concerned segments. Okay. Concerned segments. Similarly, next one is the flag register. Flag register, its size is also 16-bit, and in the separate class I will explain that is flag register, or it is also called as the program status word. Okay. And the next type of registers are index registers and pointer registers. Okay. And these index registers and point registers are used for to store the effective or offset addresses of these concerned segments. Okay, and particularly this concept is used for the memory segmentation. Okay, thank you.